Hey everyone. Good morning, afternoon. Maybe some of you are watching in the middle of the night. So whatever time zone you're in, most important is you're here. And I'm going to use the next 30 something minutes to introduce one of, I would say, my new passion domains. If you've been following me a little bit, I'm quite active in the Azure communities. Out of my job within Microsoft, I'm an Azure technical trainer, which means I'm providing technical workshop training to our partners and customers almost every week. And one of the newer services, it's in preview for now, is Azure Chaos Studio. And it's going to help you validating actually one of the topics we actually picked up like 2 sessions ago around the reliability, where I think Vishal, if I remember the name correctly, was talking about some resiliency testing, talking about how to architect your Azure workloads in a more resilient way. And I think this is like the next level, right? Where it's not just about architecting, not just about building, but you also want to test your environments and making sure that they're actually running as reliable as possible without waiting for it. So that's where my session will be about. So I'll start with introducing what is chaos engineering, and from there quickly shifting to the product, the technology, and wrapping it up with hopefully a couple of workable demos. So if you have any questions, I would say feel free to let Simon know. I know we're streaming on LinkedIn, we're streaming on YouTube, so a lot of different screens to watch over. So I'm going to hand it over to Simon to watch over that a little bit. Apart from that, if you should have any questions when you're watching this as a recording, don't hesitate reaching out. I'm active on Twitter. PDTIT is my handle there. Or shoot me an email, petender@microsoft.com. There's a little bit about me here. I'm not going to spend too much time on that. Just know that I'm quite active in the Microsoft world, started in physical data centers around 96. And then about 15 years after, jumped onto cloud, Office 365. And then once Azure became more compute ready, more enterprise environment ready, I decided to go for Azure the whole way. And that's still what I'm working on. In the free time, I'm actually still trying to go back to Azure, interesting enough, where I published a couple of books. And one of the latest parts that I'm actually working on is picking up some development stuff. But it's not about me, it's about chaos and chaos engineering, right? So first, what is chaos engineering? Now, in short, chaos engineering is, and this is like a formal definition, it's a discipline that allows you to experiment on a system in order to build confidence. So it's going to help your internal IT department. It's going to help your DevOps team, if you want, to get more confidence in the systems that our teams are building and managing and the software applications we're publishing. Where obviously the goal is not just having a confirmation for ourselves, but also making sure that when disaster strikes, that we actually have that comfort, that confidence, that our production environment can actually withstand what we call turbulent conditions here. So rephrasing it a little bit, there's three main pillars. So first of all, it's experimenting. So how does it work? You're going to inject faults, like on purpose, breaking down your production environments. I mean, how cool can it be, right? Breaking something down. I would say it's probably something that, as a little IT geek that I am, we always try to test something out. We want to make sure that obviously we learn from that, but also learning from our mistakes and avoiding more mistakes in the future. Where the other thing is really important, it's towards production. Now, there's obviously quite some flexibility because in the end, the tooling itself has no real idea if you're connecting to a production environment. Now, out of the philosophy that you can see here from the principles of chaos, it's like the foundation behind chaos engineering. I always thought it was like a pretty cool name for a metal band, but maybe that's for some other topic. But in the end, the goal is not just running a basic test in a test development staging environment, but actually targeting, preparing our production environment to make sure that it is as reliable as possible. Now, there's two different ways that I describe as the curious case of CPU pressure. Now, what I mean by that is a disaster can start pretty small. Using CPU pressure, it's actually one of the demos I have. It's where your virtual machine or an app service or any other resource you deploy in Azure might not perform as it should be. Now, the easy example, you have an e-commerce environment, you have a HR application, you have whatever kind of application, not even important for this, and something goes wrong. Now, it might start small, like a CPU spike. You got more users connecting to the workload. Maybe something else is going on in the platform on your end, or maybe you lose half of your capacity because you're running out of, I don't know, your credit card, Azure subscription budget, right? And anything else, and it starts with one single problem. So it could be a virtual machine. It could be like a key vault not being reachable, not being accessible, or maybe somebody misconfigured something in the platform where we're not always like purposely breaking down the environment, but that's exactly what chaos engineering will help us with, like simulating faults, injecting faults into the platform, and from there again, learning from it and making sure that in the near future or maybe longer term future, we're actually avoiding that problem. I also had faults out of a DevOps engineer. That's where, for example, we publish an update. Could be Azure Templates Bicep, could be some other pipeline technology, could be Azure command line scripting, and you run that update and something goes wrong. And I'm pretty sure that all of you recognize that scenario where you're super confident that the new template you're going to publish for making changes is going to run fine, is going to run solid, but eventually you find out that it's actually not always running solid. It's not to blame the platform, it's not to blame the system, but this time it's an example where it's actually me, the DevOps engineer, being the root cause of the problem, right? Or looking at it from a more complex scenario. Because if you think about any enterprise-ready application workload, it's not just a single scenario. Like, it's not only your web server going down. It's not only your database server or database resource going down. So you could stretch it out to, instead of assuming that something goes wrong in one single object, you could actually make it more complex. And that's literally how our applications are working. We deploy Azure resource groups in a region. We deploy virtual machines, single VMs or scale sets or availability sets and zones. From there, we might interact with Key Vault for our secrets. We're going to interact with network stack, which means we need network security groups, or Azure Firewall. Maybe we're using Azure SQL, we're using Cosmos database. We're now out of the basic mindset that something might go wrong with our applications, like taking again CPU pressure as an easy example. Imagine our web application is generating CPU spikes. Now, the reason behind it might be because my database backend is not performing as it should be. And eventually, I find out that my database engine is not performing as it should be because maybe somebody was running a backup job, or maybe somebody was running like some stored procedure, like a cleanup task during the middle of the day, where it actually should have been like 9 in the evening instead of 9 o'clock in the morning when all my users or customers are connected. So that's where you start troubleshooting, and you're going to hop from one system to another. And that's, again, what we're now trying to prepare ourselves for. So easy, one single scenario, and gradually going to make it more complex. So you could say it's not just the virtual machine having a problem, or the Kubernetes cluster, or Cosmos DB. Why not having all the above and all at once? And that could be like a full disaster scenario. So that's in short what our chaos engineering is about. By the way, chaos engineering, it's actually becoming more and more important. It's coming up more over the last like 18 months, you could say. So there could be a misconception that you think it's like something pretty new, something cool, something up. I talk about it almost every week in Azure DevOps classes or overall Microsoft DevOps solution trainings I'm providing for customers. Now, the funny thing is that chaos engineering is nothing new. So it was originally developed as an internal process within Netflix when they were still in their on-prem data center, where they actually wanted to test their own production environments. So that was the start of chaos engineering. And from there, it's been picked up by a lot of different hosting providers, including Azure in this case, including AWS and some other vendors. Now, from here, second part of the presentation, it's what can we do about it? So now you know a little bit more about what is chaos engineering. The next step is, okay, Peter, what tool do we have? Surprise, surprise, the tool is called Azure Chaos Studio. So for now, it's in preview. There's no super public announcement when it's going to go live, but I would say just wait until it's live, but don't wait until it's really, really live, because it means that you already can experiment with it today. You can deploy it in any possible subscription. You need to enable the resource provider for Chaos. That's like step number one. And from there, you can start experimenting. The other cool thing is that obviously, since it's in public preview, you don't have to pay for it. So that could also help you in like testing, figuring out, is this something that we could use in our production environments in the next coming months, or maybe later on. Now, in short, what is the idea with Chaos Studio? So you enable the service, you don't have to deploy anything. There are other Chaos products available, but you typically need to, like a lot of other scenarios, right? You need to deploy your own infrastructure. You're going to deploy servers. You're going to generate all the testing, the fault injections. Where now what Chaos Studio is doing is providing you that capability as a service. So it takes like 5, maybe 10 minutes, you could say, to enable the service in your subscription. And from there, the key part is obviously allocating resources, where later on I'll show you in the demo. It can be agent-based for anything that's like interacting with a virtual machine. Windows or Linux would be the mindset there. Or you can use agentless or service-based, as we call it. And that's where you can target Azure App Services, network security groups, Azure Kubernetes service, although you could also target the underlying Kubernetes infrastructure using an agent. Key Vault is another resource, and the list is obviously growing as part of the preview feature stack. Now, the tricky part, I would say, is coming up with experiments. So in short, what is an experiment? That's technically the step-by-step sequence of fault injection that you need to configure. Now, I'll show you in the portal, there's a few pre-built templates available for now. I think one is testing against an Active Directory domain controller. Second one, I don't remember for now. But the idea is once the product goes GA, that instead of you coming up with like your own fault testing, that out of the product team, you're actually going to help you in providing some sort of a library. Because in the end, we know Azure platform pretty well, because obviously it's the Microsoft product. And there might be some generic testing that could work for maybe all customer scenarios, right? If you want to test the reliability of an app service that's interconnecting with Azure SQL, with Cosmos, and that's using Key Vault, you're probably not the first customer building out that fault injection sequence. So that's where we're thinking about providing some pre-built tests. But obviously next to that, there are always like the 10% or maybe 5% that's specific to your environment that you want to test as well. And that's going to be the flexibility you can integrate. Now, looking at the diagram here, and I'll definitely try to show you in the live demo, but you start with an experiment. So before you enable a resource, like a target, as we call it, and the target, again, is agent or agentless. So that would be step number one. Even step 0.5, if you want, would force you to create a managed identity. So Chaos as the service relies on a managed identity, like an identity service principal object that you're going to use to interact with all the other Azure services. So there is role-based access in place based on the managed identity, where you're going to create one for your overall Chaos service. And then later on, each and every experiment you create also comes with its own managed identity, where obviously before running the experiment against a resource, you need to allocate the correct permissions. So it's quite locked down from a security perspective to make sure that no one can really misuse it. Because in the end, remember that the core concept of chaos engineering is targeting your production environment. Every now and then I get feedback like, okay, Peter, but what if it breaks my environment? And I was like, yeah, cool. It should break your environment. That's the whole point of running chaos engineering, where obviously customers don't like that. Developers don't like it. DevOps teams don't like it. Customers, users obviously don't like that our production environments are down. And that's something where obviously you would need to like watch over. Because again, if you generate like a CPU spike fault injection, where your CPU is going to spike to like 99% during the next 10 minutes, it might actually break your production environment. So that's something where I wouldn't say just jump in blindly and create some really cool faults, because again, remember, it's targeting your production environments. So in short, what's the flexibility you have? So there's like two different levels, you could say. So you're going to create a step. So in this scenario, we have step 1, step 2, where the idea is that a step is running in sequence. So in this case, it's step 1, where we specify CPU load over here, 99% simulation of CPU load for our target resource, like a virtual machine or a scale set, Windows, Linux, or even combining, doesn't really matter. And from there, we're going to run that simulation for 10 minutes. So we have step 1 running for 10 minutes. And after that, it's going to move to step number 2, where we can simulate something else, like read-write operations on a disk, or maybe targeting a different resource. Now, you could also move to branches, where the branch and actions are running in parallel. So think about my 2 previous slides, the CPU, curious case of CPU pressure, starting with a basic test or a basic fault injection, and moving to more complex scenarios, where you could come up with branch number 1, we're going to run a CPU pressure. And at the same time, that's quite cool because it's running in parallel, which means it's running at the same time. Like what if we have a CPU pressure and at the same time we lose network connectivity? Or we have a CPU load and we lose connectivity to key vault, which means my application cannot even pull up the secrets anymore. So that's where the complexity comes in parallel or in sequence. That's the flexibility. Sorry, that's the flexibility you have. And then from there, the selectors or the targets, as we call it, that will be your actual Azure resources, where, again, it can be single one, can be multiple ones. So that's in short what it's about. So looking at the time, I got about 10 minutes for my demo, which I think is more than good enough. So let me switch to my Azure environment, and I'll briefly walk you through some of the highlights of the configurations. So step number 1, enable Chaos Studio. So again, you need to enable it in your subscription. You go to subscription level resource provider, and you register the Microsoft.Chaos Studio resource provider. From there, you open it up, and you have 2 different steps or locations you're going to play with. One is targets. The second one is experiments. Out of the targets, that's where you're going to find all your Azure resources, the one that you can manage, the one that you can control. And as you can see, it's picking up different resource types. So I think that at least the internal previews have been around for about 18 months now, where the initial list was quite basic, like mainly targeting virtual machines and Kubernetes clusters. And gradually over the last couple of months, they're adding more and more resources into it. I'm quite limited in what I'm deploying in my subscriptions because I don't need everything, but it should give you some idea that it's not just targeting a virtual machine or a Kubernetes cluster. So you can target app services, what you see over here, targeting Key Vault, targeting a virtual machine, Windows or Linux. As long as it's a supported Azure operating system, you're basically good to go. Targeting the scale set underneath your Kubernetes cluster, some network security group, integration, Cosmos database, and a few other ones that I didn't even deploy in my environment. So from here, you have Chaos up and running, and you're going to define how can Chaos Studio as the service interact with the resource. So I already enabled it for a few of these. So if I want to target my Key Vault, select it, enable, and since it's not an operating system dependent resource, it's a service direct target. If I move to my virtual machine, it's already enabled for the virtual machine agent-based scenario. Takes a couple of minutes. It's gonna deploy the agent inside. For your Kubernetes cluster, it's relying on Chaos Mesh. So what is Chaos Mesh? It's an open source product where we're actually reusing the APIs. So Chaos Mesh is a long-standing chaos engineering open source product. And what we're doing specifically for Kubernetes, at least, is reusing some of the Chaos Mesh APIs to target our Azure Kubernetes cluster. So the nice thing is that, for example, if you have a hybrid environment where you're running Azure Kubernetes service, but sorry, you also have your Kubernetes clusters on-prem or maybe in another in another scenario, it's where you could actually rely on the same backend concept. So you're going to create your faults out of what Chaos Mesh as the API provides you with. And from there, you can actually reuse them no matter where your platform is running. So that's where it's not just 100% Azure based anymore, but we're actually embracing that open source model. The next step, once we have our targets identified, it's where you have the option to create your experiments. So I got a few of these, and I already ran some testing this morning to make sure that my demos are actually working right. But I can show you how easy it is to create a new experiment. So you define new experiment from scratch, or like I mentioned, we're working on providing you some templates. So there's one for an Azure AD outage, simulating that Azure AD as the service is not reachable for X amount of time, or there's a problem with an availability zone. One of the more common testing scenarios, I would say, that customers are asking for, because you enable virtual machines availability out of like availability zones, but somehow it's somewhat hard to test. Like, is that actually working? Unless you're gonna like randomly shut down your own VMs across the different zone concepts, where now it's actually a pre-built experiment. And again, assume that over the next coming weeks, more scenarios will be added here. Now, if you don't want to use them or they're too limited for what you want to test, nothing blocks you from obviously creating your own experiment. So what do you need? You're going to create another resource. So I'm using the portal, but technically you can automate this process, creating experiments, installing the agents or the service direct using ARM concept. So ARM templates, Bicep. I never looked into Terraform if there's something available, but knowing that you can trigger an ARM template out of Terraform, I would say if Terraform is your default infrastructure as code, you could still automate the process. So we're going to allocate our experiment as a new resource in the platform. We provide some descriptive name. So this could be the live CPU spike or something similar, where we're going to allocate our permissions. So you can play with that managed identity. I like the system assigned because it means if I'm deleting my experiment, it's also deleting the managed identity. Some organizations or customers, they actually prefer the user assigned ones, which means you're going to create one managed identity security identity object and linking that to multiple experiments. So depending a bit on how far you want to go from a security admin permission, it might be the one or the other. Most important piece is the experiment designer itself. So that's a bit what I showed in the slide. You got that step and branching model. So you start with step one, obviously, and you have a branch where you can add multiple branches. For now, there's no real limitation on how many branches you're going to add, or you can add multiple steps. Again, remember, in parallel or sequence, that's going to decide how it's going to work. So you can provide detailed descriptions. I'm just going to keep step one and branch one, and I'm going to add an action. The action list obviously is where you need to know a little bit more what you're actually doing. So what I mean by that is if I'm targeting, like in this case, I'm going to target a virtual machine. If I'm going to select any of the Kubernetes specific testing, it's not going to do anything. Like sending a fault injection for container pods against the Kubernetes cluster towards a non-Kubernetes cluster, that's obviously going to fail because it's like, wait a minute, what are you trying to do here? Or targeting virtual machine shutdown fault injection towards Key Vault, it's obviously not going to do anything. So you still need to know a little bit, like what are we actually trying to do here? What is the fault we're going to inject? So let me take CPU pressure, where you can specify the duration. So it could be a few minutes, could be like for the next hour, I don't know. And you can specify the pressure level. So the default here, because it's a basic test, is for the next 10 minutes when you start up the experiment, we're going to inject the CPU load simulation. And for the next 10 minutes, it's gradually going to 95%. So it's also not like from 7% moving to 95 and keeping it 95, 10 minutes and stopping. It's gradually moving up. And I'll show you what it looks like. From there, you're going to target your resource. So I only have one virtual machine, but if I have more VMs, you could actually build out, target my web virtual machines for 10 minutes, and at the same time, target my database VMs, target my domain controller VM. That would be the idea. And that's pretty much it. So you can add a delay, for example. That's an interesting one. Like wait for 10 minutes, and after 10 minutes, we're going to add a new branch. And again, it goes back to like, what are the disaster testing we want to go through? Do we want to simulate basic faults? And I would recommend you to start with some basic faults to really know, like, what is it actually doing? How does it work? What is the impact on my workload? Where from there, you're going to bring in some additional faults. So in this case, let's say we have CPU pressure, and I'm going to add another branch if it comes through. There we go, where we have all the other options. So like disable auto scaling is a fun one if you have a scale set, for example, where now you're going to disable auto scaling. Disk IO pressure, pretty cool, because CPU load together with disk IO load, together with maybe a network disconnect, that's almost like blowing up your own data center. Yes, Peter actually did that in the past in physical data centers, depending a bit on the customer, but I remember some of them where we literally unplugged the power of a data center, like literally shutting down everything. And then hoping that on the other side of the campus, the disaster recovery building was actually taking over. Pretty cool fun, and now you can actually simulate about the same in an Azure environment. All the way to, for example, killing a process. So if you have, like, let's say SQL.exe or any other process, not important, you could actually stop that process. And that's interesting because it's not only targeting the operating system, it's not only targeting the system part of it, but it now also allows you to actually target applications. Because in a lot of cases, you're going to run like a health check. Let's say a load balancer health check is going to validate, hey, server, are you there? Hey, server, are you there? But it's not always checking back on the lower level. And that's something you could inject now as well. Or shutting down a cloud service. So app services, I would say, is one of these scenarios where you could like simulate the fault. You go into the Azure portal, you stop Azure App Service, where now you could actually integrate it as well, even in a virtual machine scenario. So that's actually quite cool. We were doing disk IO pressure, right? So we're going to do premium storage, spike some stuff, and I'm going to target my virtual machine as well. There we go. Review and create, and again, you can automate this experiment creation using ARM, using Bicep, where in the end, it's nothing more than any other Azure scenario. It's going to create that experiment, so it takes like a minute, but I'm not going to wait for it. I'll show you what I did with my Kubernetes AKS testing, where this time, obviously, I'm targeting my Kubernetes. And let me move to an edit here, where I'm using the AKS Chaos mesh pod. So that's like randomly stopping, starting, restarting, and killing pods, where it's now relying on some JSON language. So remember, it's coming from Chaos Mesh. So we need to follow the capability of the APIs. And instead of just completing some forms, you need to use some JSON language. But that's what I meant before. If you use Chaos Mesh on-prem or AWS or anywhere else on the platform, you build your JSON setting script and you're going to hand it over and it's going to recognize it. So reusing the standards we have. Now from here, I've got a couple of minutes left. So we have our experiments. Obviously, the next thing is actually running one. So you go into an experiment, you click start, and it starts running. So I'll give it like a couple of seconds here. So you can see it starts pre-processing, and eventually it's going to run for X amount of time. You can see that only this morning, like about 90 minutes ago, I ran the same test because obviously I don't want to wait here for 10 minutes and showing you what it's about. So if I switch to my, oh, that one has got deployed. So if I go to my Kubernetes, the thing is obviously like, how do I know that it actually did something, right? So what you can do, and it's a pretty basic validation, but during the time of my testing, I went into workloads. I picked my pod service where I'm running the setting of whatever happens in my AKS cluster. I will always want to have 5 pods up and running. And what you can see here is that during that time, it's now moved up the restart count. So it's been running for 10 minutes. I got a whole bunch of other pods running. So it's somewhat randomly picking out the order. So that's a cool thing because it's like shuffling around the pods testing, you could say. And I can see that for this one, each and every running container got restarted 2 times. A few other ones might be 1, a few other ones might be 2, or some of them might actually have no restart count at all. So let's see, like this one, my monitoring hasn't been touched. And the thing is that I didn't specify anything. So it's literally randomly connecting to the cluster, looking at the pod behavior, and randomly stopping them, killing them, gracefully shutting down, and then still obviously relying on the Kubernetes. And that's the cool thing again, because again, remember, it's production, right? So if you have your Kubernetes running, you're going to kill a pod, but Kubernetes goes like, wait a minute, why do you kill my pod? I'm going to restart it. And that's where you can actually validate the behavior. Or the virtual machine, sorry, virtual machine was the other scenario. Simon, how we're doing on time? Because I lost track of time a bit because we started a little bit later.
A couple of minutes, Peter, it's okay.
12 minutes?
You have a couple of minutes, yeah.
Good, perfect timing. So for the virtual machine, did the same. So what you could do here is going into your metrics, then checking over here for CPU, where if I check back for the last hour, maybe, if it's still on there, nope, a little bit further out, last 4 hours, there we go. So this is my 95% CPU spike, then it's dropping a little bit, and then it's going crazy again. And then over here, like 8:50 something this morning, my local time here in Washington, and that's where my test was done. Now, there's no, I would say, built-in monitoring yet, where you run the testing, you run your experiments, and the only thing it shows is like it's running or it's not running, right? So that's where you still need to have your monitoring tools, your observability, like you would do in a real production environment without chaos testing. So nothing's really changing, it's just automating your testing. Or maybe one last one that I can show you is the network security group testing. By the way, it failed when I deployed it. Why? Because it errors out here on access denied, and that's where that managed identity needs to have the correct permissions to interact with the resource. So you would go into the resource IAM or role-based access and specifying that your chaos experiment actually needs permissions to interact with the platform. Now, if I start this again, and I move over to my NSG, what it's going to do, for example, I'm not sure if it's going to show up as fast as I want to, but what it's going to do here is injecting a fault. So I created an experiment simulating like a DNS outage, where from the virtual machine connecting to the outside world, I'm simulating a TCP DNS port 53 failure. So what it does out of that experiment is injecting a random NSG rule during the X amount of time of the fault. And after the fault is complete, it's nicely cleaning it up again. I got a screenshot actually somewhere. So if you want to see it in action, then I would say let me know. Now, with that, keeping time in consideration, I'm going to wrap it up here. So in short, we talked about chaos engineering. We talked about Azure Chaos Studio, the product currently in preview, and it should go live at some point in time. I have no idea about the exact timeline. I'm just a trainer. I'm not part of the product team, right? So I can only rely on the public information we have. Talking about public information, if you go like, oh my God, this was cool, but it should have been longer than 35 minutes. You can blame Simon for that. It's not my fault. Oh, cool. It's not my fault, but it was my fault injection. How amazing. So there is public documentation available already. Go to learn.microsoft.com/Azure/Chaos Studio. And if you want to go through some of the demos I showed you, there is a detailed description on the agent-based virtual machine CPU load. There is one on AKS, and there's actually already a bunch more that I didn't even have time to show you. With that, I'm going to close out. Thank you for being here. Again, if you want to stay in touch, if you do have any questions, don't hesitate reaching out on Twitter @PDTIT, or follow my blog, where actually I'm almost done with writing up a blog post regarding chaos engineering. Should go live over the weekend. And if you want to send an email, petender@microsoft.com. Simon.